Assalamu alaikum everyone. This is Light School Noshara campus. I'm your chemistry teacher. I hope everyone is fine, staying at home and enjoying their vacation. Is it so? Today's topic is on page number 52 and it is isotopes. If we read the definition, we'll come to know that isotopes are the atoms of the same element which have same atomic number but different mass number. So first we should know what atomic number and what mass number is, right? Look at this image. What do we have? Suppose this is our nucleus. Nucleus has two main entities, neutron and proton. Neutron has a charge 0. This means no charge, whereas proton has positive charge. And outside the nucleus, in particular orbits, electrons revolve. According to the rule, our first shell, which is known as K shell has an accommodation of 2 electrons, whereas L can accommodate 8 electrons. Right? As a general rule, what should we know? We should know that the number of protons are always equal to number of electrons, but if the atom is in neutral form. What does it mean? It means that in a chemical reaction, usually what happens, suppose there are 7 electrons, so what will it do? From outside, it wants to have 8 electrons. Always an element want to complete its octet, means it want to have 8 electrons in its outermost shell, and suppose it's having 7 electrons, so it do need one more electron to fill its shell, right? So what will it do? It will find, as soon as it find an electron outside, it will just attract that electron into it. And whenever an atom attracts or gets an electron from outside, we say that it is now a negatively charged ion. And negatively charged ion is known as anion. So what do we have now? We will see that now the electron, it has an extra electron, whereas the proton remains less, right? So what is the case? The case is, in any neutral atom, if the proton or if the number of proton is 7, this means that the number of electron will also be 7. I hope up till now it's clear to everyone. So what an atomic number is? Atomic number is number of protons present in the nucleus of an atom or number of electrons present in the shells of a neutral atom, right? So if there are 2 protons in an atom, we will say its atomic number is 2. Right? Alright, and obviously if there are 2 protons, so the neutral atom will have how many electrons? 2 electrons, and that is why it is neutral, that there are 2 protons, 2 electrons. Positive and negative charges will cancel each other, and as a result we will have 0 charge, so your atom will be neutral. Now come towards mass number. What is mass number? So mass number is the total number of neutron and proton in the nucleus of an atom. Okay, for example, if an atom is having 7 protons and it is having 7 neutrons, so what will be the case? We will have as a result 14 neutrons, 14 atomic mass. The atom will have mass number of 14. If the atom is having, suppose we are having another atom, it has 1 proton whereas 2 neutrons. So what will be its mass number? Its mass number will be 3. Whereas its atomic number will be, what is atomic number? Atomic number is number of protons. So how many protons are here? There is only 1 proton. So this means that its mass number will be 3 and its atomic number will be 1. Right? Similarly, if I'm having another element, and this element is having atomic number 1 and neutron number 1, so a total mass number will be 2, whereas the proton number will be 1. So this element is having 1 proton and this element is having 1 proton. So whenever the atomic numbers of an element are same, whereas mass number are different from each other, we call it isotope. Okay, so what's the definition of an isotope? Isotopes are the atoms of the same element. Same element means they will have same atomic number, whereas their mass number is different from each other. Now if someone asks you why is the mass number different, so the reason will be the mass number is different because of having different number of neutrons, right? So if you read it here now, what is it? It says the difference in mass number in an atom of an element is due to difference in number of neutrons. In other words, we can say these are the atoms of the same element which have same number of protons and electrons but different number of neutrons. Isotopes have same chemical properties but different physical properties. Now, how is it? What happens? There are two types of properties of each element. One are known as chemical properties, other are known as physical properties. Okay? Chemical properties mean how they interact with other elements, and when they interact with other elements, that interaction is because of number of electrons or presence of electrons. So only electrons are involved in the chemical reactions. So electrons or number of protons or atomic number remains same for isotopes. That's why chemical properties are same, because number of electrons doesn't change, whereas mass number changes, and that mass number causes difference in physical properties. For example, an element having mass number 3 will have less density as compared to an element having mass number 4. The element having mass number 3 will be less dense as compared to mass number 4 of the same element, right? And then similarly, other physical properties are boiling point, melting point, etc. Further if we read, so then we will understand what does it really mean. So examples of isotopes which they have given that as isotopes of hydrogen. Hydrogen usually have 3 isotopes. These 3 isotopes are known as protium, deuterium and tritium. Symbol of hydrogen is capital H. And do not forget that hydrogen is the lightest element in the periodic table, and it is placed at position 1 in the periodic table. This means that its atomic number is 1, and we always write down atomic number at the subscript, place of subscript, right? So 1, 1, 1. This means that hydrogen's atomic number is 1. All are having 1 proton, all are having 1 electron. So if I make a sketch for it, I'm not having that is its nucleus. So nucleus has protons. How many protons? 1. How many electrons? 1. Similarly, for the case of deuterium, let's make it a bit large. How many protons do we have? 1. And how many electrons do we have? 1. In the case of tritium, what do we have? Proton 1, whereas electron is also 1, right? But if you look into mass number of protium, so protium mass is 1. And according to the definition, mass number is equal to number of neutron plus number of proton. So if I want to find out how many neutrons are here, what will I do? I know mass number, that is 1. I don't know how many neutrons are here. I will put it in a neutron, whereas I know how many protons are here, 1. So to find out how many neutrons are here, I will remove this proton, or I will transfer it at the other side of equal. So what will I get? I will get 1 minus 1. If this is plus, so by placing it at the opposite side, its sign will be changed. Plus will be changed into minus. 1 will remain 1. It is equal to neutron. So this means how many neutrons are here? That are 0. So in protium, there are 0 neutrons. Now let's find how many neutrons are there in deuterium. In the case of deuterium, the mass number is 2. Okay, deuterium, the mass number is 2. Deuterium is also known as heavy water because its density is more as compared to simple water. Okay. Deuterium oxide is known as heavy water, alright. Alright, so mass number of deuterium is equal to number of neutron plus number of proton. I know the mass number is 2. I don't know about number of neutron, but I do know number of proton, that is number of proton is 1. Right? So in this case, let's bring this plus over here. So plus 1 will be changed into minus 1. It is equal to number of neutron. So in this case, I will get 1 equal to neutron. So in deuterium, how many neutrons do we have? We have only 1 neutron, whereas in protium, we had 0 neutron. Right? Now in the case of tritium, mass number is 3. So 3 minus 1 will be 2. This means that neutron number is 2. So in all these, the number of proton is same, whereas number of neutrons are changed. For protium, number of neutron is 0. For deuterium, it's 1. For tritium, it's 2. Right? So isotopes, number of protons are always same, whereas number of neutrons, number of mass number is different. That's because of changes in number of neutrons. Right? And then in your book, if you read over here, what do they say? They say it's the most abundant isotope. What is the most abundant isotope? That is, for example, if in the atmosphere we have 100% of hydrogen, so in this hydrogen 99.985% we do have protium, whereas 0.015% we have deuterium. Right? And tritium is found in rare percentage. That's why they haven't shown anything. Alright, so if you read over here, isotopes of hydrogen, this is protium. Proton having charge of plus electron, only 1 electron, 1 proton, 1 each one. How many neutrons are here? 0. Isotopic percentage abundance is 99.85. Okay. In case of deuterium, 1 proton, 1 neutron, 1 electron, 1 each 2. Proton and neutron will be added, so it will give you 1 1 2. Number of neutron is 1. 0.015 is abundance. In case of tritium, there are 2 neutrons and 1 proton. What will be the mass number? The mass number is 3. How many neutrons are present here? There are 2. What is the mass number? 1 2 3. And what is the atomic number? That is 1. and it is very rare isotope, right? Now if you look over here, a table of physical properties of water and heavy water, H2O simple water whereas D2O is heavy water, is given to you. In this case, molecular mass is usually shown in the unit of AMU, atomic mass unit. So what happens here, H2O is present in the atomic mass unit of, or the molecular mass of water is 18.02, whereas heavy water is 20.03. So which one is heavier? That is deuterium. Density at 0 degrees Celsius, water's density is 1 gram per centimeter cube, whereas deuterium or heavy water is having 1.105. It means that it is having more density. Coming towards melting point, so melting point of water is 0 degrees Celsius, whereas of deuterium is 3.82. It will be melted, right? So it has again increased. And boiling point of water is 100 degrees Celsius, whereas of deuterium it is 101.42. Again, it has more boiling point temperature, right? So the summary of today's lecture is that isotopes are atoms of the same element which have same atomic number but different mass number. The mass number is different because of having different number of neutrons, right? And the chemical properties of the isotopes are same because all are having same number of electrons, and electrons are involved in chemical reactions, whereas the physical properties like density, mass number, melting point, boiling point, etc. are different because they depend on number of neutrons. So if number of neutrons are more, the density and all those properties will be more or change from each other, right? So rest of the two topics, chlorine's isotope, isotope of uranium and isotope of carbon are same. So what you have to do, read them and try to understand them. Thank you very much. Have a good day. Bye bye.